Oh, okay then. So we want to find out the pressure of a bit of butter on the ground there. So this is the area that we're going to be using, and the force is going to be the weight of the butter. By the time we've got the pressure, which is the force divided by the area, that's what pressure is, remember, we'll know the number of newtons that there would be of butter for a whole pallet full, a whole meter by a meter, a whole square meter of butter. How much force would there be acting down on the pallet? So that's what we're trying to find, the pressure of the force due to the butter. So for that we need two measurements. First measurement is the force, which is the weight. So to get that, the first thing we're going to need to do is to get the mass of the butter. You can see it's coming up as 254 grams, even though it's a 250 gram packet. The 250 grams refers to the contents. We've also got the mass of the foil. So I'm going to start off with 254 grams is the mass, but because we want to work in newtons, we're going to have to convert that into kilograms. So you divide that by 1,000 and you get 0.254 kilograms. Now, because we want the weight, the force acting down, then we're going to need to multiply that by 9.8. So we've got 0.254 times 9.8 gives 2.489. We're going to call that 2.49 newtons. That's now the force acting down in newtons. So we've got the force there. That's a good start. In terms of the area, we're going to need the length times the breadth. The length, I'm going to be quite precise here. I'm reading that as 93 millimeters. So the length is 93 millimeters, but we've got to work in meters because we want an area in square meters. So dividing that by 1,000 gives 0.093 meters. That's okay. The breadth is 6 centimeters. Yep, happy with that. 6 centimeters. And again, you could use 60 millimeters. I'm just going to use 6 centimeters so I can show you that you change that by dividing by 100 this time because it's centimeters, 0.06 meters. The area is length times the breadth. So we've got 0.093 times 0.06, and that gives a number 5.58 times 10 to the minus 3 on the calculator, which you can put down as your answer if you want, even if you're not quite sure what it means. But that means that you've got 0.00558, and that's in square meters. That's really important that we have that in square meters. So to get the pressure, that's the force divided by the area. The force is at 2.49 divided by the area, which is our 0.00558, and we do that in the calculator. So we've got 2.49 divided by 0.00558 equals 446.23. We'll take it to three significant figures. 446 newtons per square meter. Nm minus 2. That's the pressure. That's your answer. And that means that if you had a whole slab, a whole pallet, 1 meter by 1 meter of butter, stacked butter like that there, then the total force acting down would be 446 newtons for that square meter, which is the same weight as a small child. So fascinating, but that's the way you do pressure force area calculations if you're given the mass and you're given the length and the breadth.